So in the last video, we looked at an introduction to complex numbers, and we're really focusing on surds and square roots and being able to manipulate them. The reason for that is because we're building towards what complex numbers are. Now, before we've considered roots and the roots of functions. So if you were to imagine a quadratic equation, we imagine this as being the real roots. Those two values here, these two values there. Or even if the curve looked like this and was only hitting it at one point, hitting the x-axis at one point, you could consider that to be the roots. Now in this case there are two unique real roots, and in this case it would be the discriminant, so the bit that's inside the square root of the minus b formula. So the minus b formula is x is equal to minus b plus or minus the square root b squared minus 4ac all over 2a. This part here is called the discriminant. So if the discriminant b squared minus 4ac is greater than 0, we have two unique real roots. If we have two identical real roots, we have a scenario where the discriminant is actually equals to 0. And if the graph or the curve doesn't cross the x-axis at all, we say it has two imaginary roots. And in this case, the discriminant, b squared minus 4ac, is less than 0. And it's this scenario here, where the discriminant is imaginary or not real, that we run into an issue. Because if you just take your calculator out and type in the square root of minus 9, the calculator will say math errors, and we cannot do it. So that's why we need imaginary numbers. Now, here is a little bit more general information on what a complex number is. I'm actually going to come to that in a second. I'll scroll down and give myself a little bit more space, actually. Here we go. So, if we were dealing with square roots, let's say minus 9, for example, we know from the previous video that we can break that apart and have it as 3 times minus 3, but we still run into an issue. Square root of 3 times square root of minus 3. We're still having a minus square root, so it doesn't really help us. Okay. What we can do though is say that it's square root of 9 times minus 1, which would give you the square root of 9. Square root minus 1. What's the square root of 9? It's plus or minus 3. Okay, well let's just go with plus 3. It's plus 3 because the square root was already present in the question. So it's plus 3. Okay, well what about the square root of the minus 1? Well, that's where we run into an issue because, well, we don't have the square root of a minus number. So what we define is I squared. We define I squared as being minus 1. And then following that, I, if you square root both sides, square root I squared, you'd get I is equal to the square root of minus 1. That is just a fact. I is equal to the square root of minus 1. Done. I is, it's not so much a variable, it's more a value. It is fixed. It is a value that is fixed. So we get plus 3i. Okay, and that goes for any square root. We could say the square root of minus 16 is split apart to 16 times minus 1. Square root of 16, square root minus 1 ends up being 4i. And we leave it like that. So again, I is the imaginary number. Okay, I is the imaginary number. Effectively, you can treat it like x or y. You can treat it as if it was another variable. So then, well, we haven't talked about complex numbers yet. So that builds on to what a complex number is. A complex number is a number that is a combination. So this is from the log tables. A complex number is a plus bi, where a is an element of the real numbers and b is an element of the real numbers. I squared is equal to minus 1, which implies that I is equal to the square root of minus 1. So a complex number is a combination of two parts. It is a real part and it is an imaginary part. Okay, so the imaginary part, and that's the actual phrase that we use, is the coefficient of I. So it's the number in front of I. Together, an imaginary part and a real part form a complex number. So that right there, that's what a complex number is. Okay, so that's a load of theoretical talk about complex numbers. But it's nearly easiest to show you an equation and why we need them. So if we have an equation here, noting that our variable is x, we can use the minus b formula, saying x is equal to minus 10, which would be 10, plus or minus the square root b squared, so minus 10 squared minus 4 by 1 by 26, all over 2a. Which would be 2 by 1. I'm just going to use the smaller pen. So x is equal to 10 plus or minus the square root minus 10 squared, which would be 100, minus 4 times 26, which is 100 and should be 104, 104 all over 2. So x is equal to 10 plus or minus the square root of minus 4 over 2. Okay, now we run into the issue, a minus in the square root. So we treat both options, plus minus 4 over 2. X is equal to 10 minus square root of minus 4 over 2. X is equal to 10. Now remember, square root of minus 4 is equal to the square root of 4 times minus 1. Square root of 4 minus 1. 2i. So this could be written as plus 2i over 2, or x is equal to 10 minus 2i over 2. And we go x is equal to 10 divided by 2 is 5. 2 divided by 2 is 1, so you just get I. Or x is equal to 10 divided by 2 is 5 minus 1i. Okay? And note, we had negatives inside the square roots, so we know we're going to get i's at the end. Okay, we're pretty okay with getting i's at the end. That's fine. Okay, so this is an equation where the roots are not real. The roots are not real. Generally speaking, if you had an equation with x's in it, you would expect the roots to be real. More often with complex numbers, we end up having the equations written as z squared minus 10z plus 26 is equal to 0. Z is by far the more common variable in complex numbers. So to show you a question in which this might happen, it would be like this. Now you might want to, I just don't want to scroll down to show you the question, but here, 2z squared minus 8z plus 9. You might have noticed that I write my z's as 2z squared minus 8z plus 9 is equal to 0. Look, if you don't have the neatest of writing like myself, it's very useful to write your z's like that with the line through it, because it's going to stop you making a mistake. You might want to take a chance to pause the video and just try to use the minus b formula on this question. Otherwise, in 2 seconds, I'm going to continue on. Okay, so the solution to it. So we know our a, b, and our c. B is the coefficient of z, a is the coefficient of z squared, and 9 is the constant at the end. I've written down my minus b formula. Note, when you're subbing in the b, make sure it's the whole thing squared, so it's the minus being squared as well. So you should get a positive out of this, but with a z as the variable in the question, we would expect to be happy to have a minus inside the square root. That just shows you again that it does not cross the x-axis and we have imaginary roots. Okay, so the square root of, the quick way of doing this, square root of 8, you could just, square root of minus 8, you could just do square root of 8, square root of minus 1. That you can type into your calculator. You're okay at typing that into your calculator, you'll get 2 root 2. But we know the square root of, I'll leave that there, sure. Square root of 8 square root minus 1. That's 2 root 2 I. So we'd kind of expect that that's okay. 4 divides into 8 2 times. 4 divides into this section a little bit trickier. Okay. The 4 divides in now. Definitely need more space to explain this a little bit more detailed. So we can have z is equal to, this bit's fine, 2 plus 2 root 2 over 2 by 2 I. Z is equal to 2 minus 2 root 2 over 2 by 2 I. And what happens then? Well, the 2 and the 2 will cancel. So we get z is equal to 2 plus root 2 over 2i. Now, I'm sure I have said it to you before, but to remind you, this 2 root 2 in your, this 2 over root 2, 2 over root 2, it's really common for your calculator to spit that as an answer back to you. You need to be aware that square root of 2 over 2 could also be written as root 2 over root 2 root 2, which then gets simplified down to 1 over root 2 because they cancel as well. Very similar again, you might get 2 over root 2 in a question, and you should be capable of rewriting that as simply root 2. You should be aware that 2 over root 2 is 2. It's sort of something to, I would say learn off by heart, but I think it's more important that you just recognize it, recognize that you'd go down that road. Okay, so as I said before, when we have a negative inside the square root, it's absolutely fine. We just break it apart, and then you can use your calculator to calculate this bit right here. And then what do we know about square root of minus 1? It is I. It's just a fact. It is I. Okay. Similar with this one. Break it apart, so you've the square root of minus 1, and then square root of 36. Fine, 6. Square root of minus 20. Okay, so I actually think all of these are very similar to the start of the previous video, the questions that we did. It's square root of 20 now. You don't have to take your time in breaking that down. You can just use your calculator straight away. Stick that bang into your calculator and it'll spit out 2 root 5 back out at you. Okay, this question then. What we do with it? Well, we know there's sort of 2 veins of thought here. Generally, I like to remind people that if it's an equation and the highest power is 2, spelling height there, highest power is 2. So we should have 2 answers. Okay, so you can either spot that you're going to go, actually no, one way to do it really. Go x squared is equal to minus 25. And we want x on its own. So x is equal to the square root of minus 25. X is equal to the square root of 25 square root minus 1. What do I know about square root of minus 1? Square root of minus 1 is I. Square root of 25 is 5. I. Now, I'm kind of breaking my own rule here. I said we should have 2 answers. Well, that's only 1 answer. How do I have 2 answers? Because if I introduce a square root, take the plus and minus version. If square root is in question, only take positive version. So you might notice that, that's not how you spell version. When the question had said square root of minus 16, I just said that's 4i. But if I had introduced that to solve the square root to solve the question, so it's plus or minus, and we like to write it as x is equal to 0 plus 5i, x is equal to 0 minus 5i. So we like to include the real part here. The 0 in this case is the real part, the imaginary part is the 5 and the minus 5. Okay, so if you have a scenario like this, subtract 25 from both sides, square root both sides, and then solve. But make sure if you're introducing the square root, you take the plus and the minus version. Okay, so there's a nice little cyclical nature of I here. If I multiply I by I get I squared. If I multiply square root of minus 1 by the square root of minus 1, I just get the square root of minus 1. Sorry, I get minus 1. Okay. So I by I is equal to I squared, square root of minus 1, square root of minus 1 is equal to minus 1. What if I continue multiplying by I? What's I squared by I? It's I cubed. What's minus 1 times the square root of minus 1? Is minus the square root of minus 1. Okay, so minus square root of minus 1 by minus square root of minus 1 by minus square root of minus 1 ends up being minus the square root of minus 1. And again, if I multiply by I, I'm going to get I to the power of 4 here. I by I by I by I to the power of 4. Square root of minus 1 by square root of minus 1 by square root of minus 1. Well, what's square root of minus 1 by the square root of minus 1? This is minus 1. What's square root of minus 1 by the square root of minus 1? That's minus 1. What's minus 1 by minus 1? Is 1. So I to the power of 4 is 1. I to the power of 4 is 1. That's really important. Well, we can also note then I to the power of 5 is I to the power of 4 times I. What do I know about I to the power of 4? That is just the number 1. So I to the power of 5 is the same as I. Similarly, I to the power of 6 is going to be the same as I squared. I to the power of 7 is equal to I cubed. I to the power of 8. Well, what's this? Let's break this down. I to the power of 8 is equal to I to the power of 4 multiplied by I to the power of 4. What's I to the power of 4? It's 1 times 1. So I to the power of 8 is equal to 1. But that's the same as I to the power of 4. Don't want it there. That's the same as I to the power of 4 equaling 1. So there's a cyclical nature to this. The cyclical nature is that I multiplied by I gives I squared, multiplied by I gives I cubed, multiplied by I gives I to the 4. And if you multiply by I again, you're going to get back to the same value of what I is. So if we're looking at this question, I to the power of 30, I to the power of 30, find what that is equal to. Well, I know if I were to subtract 4 from the power, it would be the same thing. So it's the same as I to the power of 26, which is the same as I to the power of 22, which is the same as I to the power of 18, which is the same as I to the power of 14, which is the same as I to the power of 10, which is the same as I to the power of 6, which is the same as I to the power of 2. I to the power of 2 is minus 1. Now, bit long and complicated that, subtracting 4 each time. What we could have done is gone I to the power of 30 is the same as I to the power of 30 minus 4 times any number. So it could be 4 times 5. 4 times 5. As long as I'm subtracting some quantity of 4. So 4 times 5 is 20, so that's I to the power of 10. I to the power of 10 minus 4, I could do it by 2. I to the power of 2, and that would be minus 1 again. So you're just subtracting 4 from the power, and it's the same. So again, you could type that into your calculator, or you could just go, you could go 19 on your calculator, minus 4 is 15, minus 4 is 11. Keep hitting minus 4 now. And you get that's the same as I to the power of 3. I to the power of 3. I to the power of 3 is minus the square root of minus 1. But this one? Well, if it's the same as minusing, surely it's the same as adding 4. So I to the minus 4 is equal to I to the power of minus 4 plus 4. I to the power of 0. Anything to the power of 0. Students keep getting this wrong. Students, I know you've gotten it wrong before, and I'm sure people 100 years from now will get this wrong. But you have a lovely little calculator beside you. Just go 5 to the power of 0. Any number to the power of 0 is 1. And your calculator will tell you it's 1, so we know I to the power of 0 is 1. Done. Don't try and remember it if you don't have to. With a question like this, it's only when we're multiplying that we add the powers. So try and find out what I to the power of 16 is the same as. I to the power of 16. I to the power of 16, you can subtract 4, subtract 4, subtract 4, subtract 4. That's I to the power of 0, so that's 1. This is subtract 4, you'd get I to the power of 6. Subtract 4, you get I to the power of 2. Subtract, what am I thinking? Subtract 4, you get I to the power of 2. Subtract 4, you get I to the power of 8. Subtract 4 again, I to the power of 4. I to the power of 4 is, well, I to the power of 4. What do I know about I to the power of 4? Let's worry about that in a second. This as well could be written as I to the power of 4. This one, I to the power of 16, is I to the power of 12. I to the power of 8, I to the power of 4. I could have stopped there because I know what I to the power of 4 is. Remind you up here, I to the power of 4 is 1. I to the power of 4 is 1. I to the power of 4 is 1. Or you could go again, I to the power of 0. I to the power of 0, anything to the power of 0 is 1 as well. So similarly here, I to the power of 4, I know is 1. And I to the power of 4, I can rub that out and write it down as a 1. Now, what's I squared? Well, I squared is equal to minus 1. That was the fact that we need to remember. That's where complex numbers have come from. So it's 1, minus 1, minus 1, minus 1, which leaves us with minus 2 is the answer here. Similarly over here then, we're going to have an answer with square roots, I think. Here, because I to the power of 3 is minus the square root of minus 1. Here, I to the power of 11, and I'll actually leave that as I to the power of, well, I can put it as I squared times I. Here, I can put this as minus, subtract 4 would be 7, subtract 4 would be 3. So I could put it as I to the power of 3. Subtract 4 would be 13. Subtract 4 from the power from 13 would be 9. Subtract 4 would be 5. And subtract 4 would be 1. So it's just I. And here, slow it down and go, well, 29 minus 4, minus 4, minus 4, minus 4, minus 4, minus 4. And see what we get down to. I to the power of 5 minus 4 again. I to the power of 1. So I to the power of 1. Which I'd just write down as I. Okay, well, what about this? This I squared. I squared is minus 1, so I get minus 1I. Minus 1I looks funny. Just write it as minus I. But here, this is I squared I plus 2I. The 2I is coming from I plus I. And the I cubed gets changed to I squared and I. I squared is the same as minus 1. So it's minus I minus 1I plus 2I. I plus 2I will just leave us with 2I. Okay, I'm sure there's quicker and easier ways to do it, but again, you can just keep subtracting 4 from the powers until you get down to an I to the power of 4 or smaller. And finally for the video, let's look at this one. Last question for the video. It's 2 times Z1. Now they tell us what Z1 is. Z1 is 2 plus 4i, so it's 2 by 2 plus 4i plus Z2. Z2 is 3 minus I. 2 by 2 is 4. 2 by 4 is 8i plus 3 minus I. and we add the real parts only. So it's 4 plus 3 gives us 7, and the imaginary parts only. So 8 minus 1i would be plus 7i. And it's exactly the same for all of these questions. I just gets treated like an x, as you would be aware of or familiar with. Again, I multiplied by I is equal to I squared. I squared.